Right, good morning. This morning we're joined by Mariet Venter from the SKA, which is now called SARAO or something similar. Morning, Mariet.
Morning.
How do you pronounce it?
It's SARAO, South African Radio Astronomy Observatory.
Could you give me a brief overview of how you got into engineering?
I probably got my first computer, or us as a family, when I was in grade 1. I was basically hooked, so I played computer games like 24/7. It started with a love for computers, and then in high school I really started excelling in maths and physics as well. So it was kind of cut out for me, it feels. I'm a bit of a space junkie as well, so NASA and everything, just everything that was kind of surrounding me and in my environment made me excited for electronic engineering. So I knew that I wanted to do electronic engineering from the start as well.
Yeah, it's interesting. I never thought about it, but we're both observing space from Earth and we're also sending stuff into space at Stellenbosch University. It's a nice broad coverage of space. Could you maybe expand a bit on what you do at the, I can't pronounce it, SARAO?
Just say SKA is fine. Just say
SKA.
Okay, so I'm an RF engineer, and RF stands for radio frequency. So basically that is the transmitting and receiving of radio signals. So we design components, analyze components that can transmit and receive like radio frequencies, and also that just any radio frequencies that propagate in a medium or in free space. So basically I'm an antenna engineer, and I work on the like what we call the front end of the telescope. So the telescope itself before they digitize the signals. So basically on a daily basis, I work a lot with what we call EM or electromagnetic simulations. So that is software that was designed to solve what we call Maxwell's equations, which when you study engineering and you do electromagnetics, then you'll learn about Maxwell's equations, which, as I said, describe how waves transmit in a medium. So we've got this really powerful software, and basically we set up the simulations, we put the entire telescope or whatever component we want to analyze in there, and all the unknowns are solved, or all the calculus are solved by this software. So that's the tool I basically use on a daily basis, and I also code a lot. So the results that come out of that software need some post-processing, so I spend a lot of time coding as well.
Maybe a philosophical question. It looks like many of the engineers actually work with software in the end, and it includes quite a bit of coding. How important do you think the fundamentals that you learned at university are to allow you to properly do this coding and properly do the simulators?
I think it's very important. I think I didn't particularly like or enjoy coding at university, to be honest. I was inclined more to the like engineering maths and applied maths. But then obviously as you enter the workplace, you start getting more equipped in coding, so I started getting more comfortable with it. But I think it's actually a general problem-solving skill, coding, basically in the end. You've got some sort of problem, and you've got these tools and this coding language or program language that you need to solve this problem with. So I think when it comes to the philosophical side, I think the core skill is actually just problem solving. It's basically a language that you learn and that you use to problem solve. So I mean, that's a general and very important skill that you learn at university as well.
Yeah, for sure. Weren't you in my computer programming class?
I can't remember. I was trying to think this morning.
I think you were. It's a pity that you didn't enjoy it, though. But that's the way
I'm sorry. It has nothing to do with the lecturer.
No, obviously not. Obviously not.
No, not at all.
Could you help me understand maybe? It's a bit of a sensitive topic, so by all means decline to answer if you don't want.
Yeah.
How difficult was it for you as a female student to be in engineering? Because my understanding is that especially when you were studying, there weren't many female electrical and electronic engineering students.
Yeah. So I think in my final year, so I specialized in telecommunications final year, and I think we were about 70 students and like 6 females. So yes, I mean it's totally in a man's world, but it wasn't an issue for me. I think I think the kind of key thing is to let your technical ability kind of speak for itself. So I think women in engineering were in a more fortunate position than, say, women in business, where, it many times comes down to your opinion or your ability to strategize. I think that can take a lot more criticism, whereas, if you're in engineering and you're doing some technical work, I mean, if it's really up to a good standard, then there isn't really a lot that can be said about anything else.
That's a very nice perspective. Yeah, I like that very much. So you let your work speak for itself.
Yeah, so I think that's kind of the approach that I've taken in my work environment as well. So it is daunting if you walk into a class and there's only males sitting in the class. But the point is, for the next 50 minutes, just focus on the technical work that's being presented, study it as well as you can, and just don't worry about the rest.
Could you cast your mind back to when you entered the job market? What was the most revealing aspect of entering a job coming from university?
I think the amount of meetings and teamwork. So I think at university, I mean, obviously you do projects within teams, and you have your peers helping you on certain tasks. But if you walk into the working environment, you're put on projects where there's, multitudes of different engineers and different personalities, and meetings and project management. So it broadens your perspective very quickly beyond the kind of technical things that you were focused on at university. And systems engineering also comes into play. So basically integrating, and especially where I work in terms of a telescope, there's a lot of different disciplines, a lot of different engineering disciplines, and all of these components and subsystems needs to work together. So systems engineering is a big thing that comes into play, and with that comes a lot of documentation. So you really skimp on writing really good documents and having configuration management, being able to find documents that were written 10 years ago and lessons learned. So it's a lot of mixing what you're doing on a technical basis with communicating in verbal and documentation form.
Yeah, for sure. I vividly recall in high school, grade 10, I was telling the teacher, Afrikaans teacher, that I wanted to become an engineer. I really don't need languages. And I think that was a big thing that I realized very quickly, that even though you've got the technical skills and the training is very much focused on technical aspects, the communication aspects and conveying a certain message, both orally and in written form, is extremely important. And if you can't do it, then you tend to hit a bit of a glass ceiling. Could you also just take your mind a bit further back? Think about you at high school. What's the one thing that you wish you knew about engineering before you started engineering? Or if you have multiple, you can mention those as well.
I think, what I want to say, or what came to mind immediately, is the importance of engineering math. It's just such an important subject. You have to stay on top of things. Prepped for something like Engineering Week, basically, that week where you write all your subjects within 1 week. And if you...
Ooh, good point. You mean the semester week, the semester test?
Yeah, so if you get to that week at the end of, one term, right? And you've fallen behind, it's just, you won't be able to catch up before, you write a subject each day.
That's a very good point, because it takes 6 weeks to get there, and within those 6 weeks, you may have become completely lost. So those first 6 weeks are really crucial. That's a very good point. I never thought of that.
Yeah, so if you don't, so actually two things, spend a lot of time on preparing every day for the tutorial next day, because if you get behind in your tutorials, you will eventually be behind by the time you get to engineering. So I think the first year is it's just a grind. You just have to stay on top of things, and enjoy university life as well. But studying and being prepared for tutorials is really important.
Mariet, it's been an absolute pleasure talking to you today. Thank you very much for making time.
Such a big pleasure. Thanks.
Thank you.